Right. Please stand. It is a carpet. They do grab those things in the bottom. That's right. In nomine Patris et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defenda nos in prayer, contra nequitiam et insidias diaboli, est presidio. Imperet illi Deus, supplices te precamo, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animalum ervegantur in mundo, divina virtute in infernum deterrum. Amen. In nomine Patris. Okay, have your class 64 ready? I'm going to check off the first half of it. Have your notes ready for the next section coming up. Keep your homework out because we're going to read off the answers. Yes, ma'am. Just a second. Oh, Josh, you are good to go. And yes. Start back. Yes, ma'am. As soon as Johnny gets back. Okay, this is up to number 26. Can you get the whole thing to me by tomorrow? Okay. Did you get to see the video? So do that as soon as you can. And if you can get, did you get the word, get it all? Okay. I sent an email with it attached, but I'll give you a free special. I'll give you a paper copy. You guys can and the video will also have there are quite a few of them. Other videos. Some of them actually right. That's correct.
2x times 1, which is 2x. Double it, which
So
is
you're saying more about our story than I know.
Pretty much like that. Oh, I see. No. Oh, gotcha. Okay, sorry. I thought you said nobody else.
I almost got it.
Yeah. That's definitely. For people watching at home, we'll be done in just a second. You can probably go get a sandwich or something.
I know. So why
No, that was not funny. I'm sorry. No.
Okay, grab a red writing utensil, have it at the ready. Go through these, see what you got. Scoot this over, so they don't get to see me. All right, in class number 64. Whoa, this is not the right page. 60, there it is. Everybody set? Number 1, actually let me grab my own copy. Number 1, factor by GCF, grouping, unfoil, or any other method should have a GCF of 4, x to the third, y, and then inside should be parentheses 3y plus 7x squared. Let me read that again. In front should be 4 x to the third y, and then parentheses 3y plus 7x squared, close parentheses. Okay. Number 2, factors by grouping should be x plus 9 and x squared plus 2. Number 3, factors by unfoil. It's x minus 3, x minus 10. If you had x minus 10, x minus 3, that's fine. Number 4 is prime. Yeah.
Oh, wait, you're right.
Okay. Number 5, this factors twice. It factors by GCF of x plus 3, so pull x plus 3 out in front, but then you should have parentheses x squared plus 5x plus 4. That factors again by unfoil. That breaks into x plus 1, x plus 4. Your final answer should be 3 parentheses. X plus 3, x plus 1, x plus 4. And it repeats up to number 5. Yeah. Number 4 was prime. Yeah, Rosie.
Can you repeat the answer to 5?
The answer to 5, 3 parentheses. X plus 3, x plus 1, x plus 4. If that doesn't match your answer, please write it in. Number 6, factors twice. There is a GCF of -1 you pull out in front. That should leave behind x squared minus 10x plus 21. But that factors again by unfoil. You should have -1, parentheses x minus 3, parentheses x minus 7. Any repeats on that?
Wait, should we say, is that number 6?
That was number 6, yeah. The final answer should be -1 and then 2 parentheses, x minus 3, x minus 7. You can have them in back reverse order too. Number 7 is prime. Number 8, factors twice. There's a GCF of 4x, so pull that out in front. It should leave behind x squared plus 3x plus 2. But that factors again by unfoil. Final answer should be 3 parts. In front should be 4x, then 2 parentheses, x plus 1, x plus 2. And it repeats up to number 8. Yeah. Say again? Number 8, is that? Yeah. So 3 parts. There should be a 4x in front, followed by x plus 1, followed by x plus 2. Okay. So next page is a bunch of reading. Then skip over to problem number 9. The answer should be y squared plus 8y plus 16. Number 10, h squared plus -22h plus 121. Number 11, x squared plus 16x plus 64. Number 12, 4x squared plus 12x plus 9. Number 13, a squared plus 2ab plus b squared. And number 14, hang on your hats, it's kind of big. 9x squared y squared plus -30xy plus 25. And it repeats up number 14. Yeah. 12 was 4x squared plus 12x plus 9. Any other repeats up to number 14? Right. Scoot over to number 15. You want to see if we can do it backwards. Now 15 and 16 are at the bottom of the page, so make sure you didn't miss them. 15 is x plus 5 parentheses squared. X plus 5 parentheses. Make sure the squared's outside in the parentheses. And then the x plus 5 is inside. Number 16, x minus 5 parentheses squared. Number 17, not a binomial squared. Number 18, x plus 10 parentheses squared. Yeah.
Is it right if you wrote prime instead of not a binomial?
For now, yes. Technically, later on, there will be some things that are not prime, but they're not binomial squareds either. So they'll factor by a method we haven't covered yet. But for now, yeah, it's fine. Number 19, everybody got number 18? X plus 10 parentheses squared. 19, not a binomial squared. Should be looking at your paper, not at other people. 19 is not a binomial squared. 20 is a binomial squared. It's 2x plus 1 parentheses squared. 2x plus 1 parentheses squared. Number 21 is a binomial squared. X plus 1/2 parentheses squared. That was a tricky one. 22, not a binomial squared. 23 is a binomial squared. X minus 15 parentheses squared, or plus negative. Number 24, it is a binomial squared. xy plus 3z parentheses squared. xy plus 3z parentheses squared. 25 is not a binomial squared. 26, believe it or not, is x plus 3/4 parentheses squared. Any repeats? 1 through 26. Okay. 23 was x plus negative 15 parentheses squared. Any other repeats? Everybody good with repeats? All right, questions? Yeah. Right.
How do you do, 6?
Number 6. Let me page back. Got it. Number 6 does it factoring twice. 6 looks like this. Negative x squared plus 10x minus 21. Again, the very first thing I would do, add the opposite. There is a 1 hiding here, so it's negative 1 in front. And then I would add the opposite here. What's the very first factoring method you should always check? Eric.
GCI?
GCF is the one.
No.
Technically, no. But there's one thing I do want to pull out. Not because the number is so great, but because there's something weird.
The 1?
There is a 1. Normally I wouldn't pull that out. But there's a reason why I have to pull something out. It's called the Murgatroyd phenomenon. Go.
The negative?
If it starts negative, you got to pull out the negative GCF, even if it's a 1. So you pull out a negative 1 with leftovers. Does that make sense? If the first term is negative, you have to pull out something negative, even if it's a negative 1. What's left behind if you do that? Josh? Up and at 'em. Okay. Tune in on this, I'll get you on the next question. Yeah. What's left after you pull out a negative 1?
X squared
Ah.
plus 11.
On the right track, I'm dividing by negative 1. What's 10 divided by negative 1?
Negative 10.
Good. Negative 10x. And do the same trick. What's negative 21 divided by negative 1?
1.
See?
Negative 1.
Well, negative 21.
Oh, sorry. 21.
21. Does that make sense so far? Whenever you pull out a negative 1, the only thing that really happens is all the sign switches. Well, that didn't make any sense. All the signs switch. This turns positive, this turns negative, this turns positive. Make sense? Dividing by a negative will switch the signs, and divided by a negative 1, that's all it does. It doesn't make it bigger or smaller. So question, does this thing factor again? GCF, you're done. Does it unfoil? Yeah.
Yeah.
Can you think of two numbers that add up to negative 10 and multiply to be 21? Like,
Me?
yeah. What two numbers are kind of coming to mind? What two numbers multiply to be 21?
3 and 7.
3 and 7. as long as you make them
Negative.
right. If I had x plus 3, x plus 7, that would be close, but what's wrong? Rosa, what would be wrong with that?
Then negative, couldn't be -10,
Right, it'd be positive 10. How do you fix that?
make them negative.
Right. Negative 3 times negative 7 still works. Negative 3 times negative 7 still makes positive 21. It's so good. They multiply by 21, but they add up to give you negative 10. This is your final answer. Okay. So some problems factor more than once. Plus, eventually, I'm going to start putting problems on the board that might factor 4 or 5 times in a row. They're not too bad. They look horrible at first, but as you break them apart, they get easier and easier and easier. Next. Question. Yeah, good. 26. Take a look. Yeah, x squared plus 3 halves x plus 9/16. Oops. Now, they were asking, is this a binomial squared or not? If it isn't, then put not binomial squared. And if it is, tell me what binomial squared it came from. Can somebody recite for me the 3-step pattern for a binomial squared? Go. Square the first, double the product, square the last. Right. That means square the first had to come from here. Square the last had to come from here. Those are the two terms I'm really interested in. I'll use this to check my answer. But for now, where did the x squared come from? Maria. What did they square to get this? Don't work too hard. X. Does that make sense? Square the first, like here's the first and the last. Square the first, give you x squared. What did they square to get the last? Product. If they squared something and got this, what was the something that they started with? Now give me a hint. The top and bottom you can do separately.
3/4.
Exactly. 3 over 4. Because 3 squared is 9, 4 squared is 16. Ding, 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 ding. Now we do have to check something. Some of these are fake. The middle term has to be a double product. Can somebody tell me if it is or not? Yep.
It is because 3 over 4 plus 3 over 4 is 6 over 4. And
Yeah.
that reduces down to
3/4 x times 2, or 3/4 x plus 3/4 x is 6/4 x. And what does it reduce to?
3 over 2.
3 over 2x, which is exactly what we want. In other words, the double product, the product is 3/4 x, doubled it is 6/4 x, and that's right. In other words, it was hard to see, but this is correct. And that's your final answer. Okay. With fractions, it is a little bit more annoying to see. But do it on paper, double check the double product, pun intended, and then see if it works. If the double product does not work, I don't care how tempting this looks, it's wrong. There was one we did the other day that looked really, really good, and it was wrong. Next. Any other questions you want to see? Okay, yeah. Now, I'm assuming, Josh, do you have your worksheet? Yeah, Rosie, go.
5.
Number 5. Alrighty. X squared parentheses x plus 3 is number 5. Plus 5x parentheses x plus 3 plus 4 parentheses x plus 3. Anybody notice anything right away on that? Mary, what's suspicious about this?
You can pull out the x plus 3.
Right, there's a GCF in the parentheses. Pull the x plus 3 out in front. So I'm going to put that here, x plus 3. You don't have to double or triple it. It's just going to be plain old x plus 3. Mary, can you tell me the leftovers while they're at it?
X squared plus 5x plus 4.
Yeah. Let me see where that came from. Here's the x squared, the plus, the 5x, plus, and the 4. All the stuff that was left over from the outside. So, Eric, help me out with this one. Does this factor again? Can you think of two numbers that add up to 5 and multiply to be 4? That's not.
Oh, 1 and 4?
1 and 4, exactly. How would you write that? I got the x plus 3. But what does this look like? What does x squared split into?
X.
X and x, okay? And then what are the two numbers you said?
4 and 1.
Exactly. Plus 4 plus 1, that's your final answer. Make sense? A little more comfortable with it? Any others you want to see? Now's a good time to ask. Susan? Going once? Twice? All right. You got your notes, please. I want to talk about the second half of this worksheet called difference of two squares. You got your notes? See what these look like. This factoring method, which is the fourth factoring method, is called difference of two squares. Difference of two squares. What it looks like is something squared minus something else squared. Anything with that form should factor using this method. So far we have GCF, that's undistributing. Then we learned unfoil. We got binomial squared from yesterday. And a couple days ago we did factor by grouping. Now difference of two squares. What does it look like? Just as a quick example, I'm going to do a couple FOIL problems for you. X plus 5 times x minus 5. Andy, take this one. FOIL these for me.
It'd be x squared.
Yep.
And then, would you want me to use that shortcut thingy?
Totally up to you.
Negative 5x. And
Okay.
plus the negative 5x.
Okay.
And then 5x.
Okay.
And then,
So traditional FOIL.
negative 25.
Plus negative 25. Does anything simplify?
Yeah.
Like what?
Negative 5x and 5x
Cancel. What's the only thing left?
x squared plus negative 25.
X squared plus negative 25. I am, in one of the rare instances of my life, going to write this as a subtraction problem. First of all, for the people who are sentimental for subtraction. Second, because it is a little bit shorter. Third, for mysterious reasons of my own. Yeah.
Okay, so you basically just do x to the second and then multiply 5 and 5?
Oh, for your first shortcut, you mean?
Yeah.
Maybe. I'll tell you in a minute. Short answer, yes. What if you have x plus 7, x minus 7? Now again, there is a trick to this, and there is a pattern to this. Therese, help me out here. Foil it for me.
X squared
Yep.
plus negative 7x
Okay.
plus 7x
Okay.
plus negative 49.
Does anything simplify?
Yes. You just get rid of both the 7x's. And
Correct. What's left?
X squared plus negative 49.
Correct. X squared plus negative 49, which for my own mysterious reasons, I'm going to simplify as x squared minus 49. I'm wondering if anybody sees a potential pattern. Yeah.
You can undistribute it kind of, it'd be x times x and then 7 times 7.
Right. So in other words, what both of you are saying, you seem to be catching that x times x is x squared, and 7 times 7 is 49, and that seems to be the only terms we need to worry about. Why? Yeah.
So would you just, kind of unfold the second one, do x plus, like blank plus x or whatever, and then square negative 49?
Interesting. The answer is, I'll tell you in 45 seconds. Yeah. Plus.
You said why, because one's positive and one's negative.
One is positive, one's negative. You notice that seems to be the case all the time. Let me try x plus 10, x minus 10. Does anybody think they can guess at the final answer all the way to the end? Go, Rob.
X squared plus negative 100.
Got it. And I'm even going to write it as x squared minus 100, just in celebration. By the way, bravo. Does it make sense?
Yes.
And the short answer is yes. 1 plus 1 minus makes something cancel. It makes the two middle terms cancel, and it makes the last term negative. See if anybody can do this one. Jump to the end, go.
X squared plus negative, minus 144.
Got it. Now, can you do it backward? What if I gave you this? Quick example. It's a lot easier than you think. X squared minus 36. What two parentheses does that come from? Yeah.
X plus
Yep.
x minus 6.
Bingo. You are looking at one of the two fastest factoring methods in the book. The other one is actually binomial squared, if it works. This one's actually a little easier to see, so arguably this is the fastest of the factoring methods. Basically, if you have something squared minus something squared, this always factors. Example, I'm going to try a weird one. You can probably get it pretty easily. A squared minus b squared. Isabella, leap into the fray. What two parentheses do you think might make that work? Split a squared up into what times what?
A times A.
Yes. How about b squared?
B times B.
And then one little trick here. How do you get everything else to cancel and bubble up?
Oh, make one that's negative.
Yep. And one.
And then the other one,
Exactly. Make 1 plus, 1 minus. It should always work. This, by the way, is the generic form for difference of two squares.
Plus you.
Now this can work with some pretty big problems that become very easy to do. Does anybody have these over on the left-hand side? Anybody still ready? Okay. And this will be posted to YouTube, so you can check that too. But try this. I'm going to make it bigger and stranger looking. X to the 4th minus 1. Be brave enough to attack that one. Ooh, good sign. Yeah.
Would it be x squared plus 1,
Yep.
and then x squared plus minus 1?
Bingo. Yes. I should say something else. Yeah. Congratulations. Yes. Does this make sense? Whatever the first one is, split it in equal parts, multiply parts. Yeah. Now, try this. Let's make it even beefier. 9x squared minus 121. Be careful, I threw a 9 in there for a reason.
I have a question.
Question?
Do you just have to split the 9? Do you like split the 9?
Into
or,
what?
Like 3?
Yep. So what would this and this be? Got to
What?
split the whole thing.
Oh, it would be 3x.
Yep. And 3x. What is 121?
11.
11 and 11. And what do you put here and here?
Well, you add it and then subtract it.
You're done. What's that?
Okay.
Okay, math schmartsy pantses.
I can't
You think your suit's up?
remember.
Try this.
What's going on?
Go.
12
Let me
x
pull it down
to,
12,
to
go
the
ahead.
fifth,
X to the fifth.
y to the fourth,
Ah.
and z to the third.
Then, by the way, same thing here.
And then the first one's plus 5, and then t.
T.
And
The other
then
one is,
minus 5t.
and you're done. That's it. Does that make sense? It's big, but once you split them into equal pieces, multiply them, by the way. Don't do 72 and 72, that's adding. Make sure it's 12 times 12. X to the fifth times x to the fifth is x to the 10th. That's why it splits nicely like that. X to the fifth, y to the fourth, z to the third, click, click, click all the way down. That makes sense. Now, curveball again.
Mr. Costa.
Yes, sir.
So, would you give us any numbers as like the second number that won't like square easily? Like
You
5 times
read
5.
my mind. I was just gonna write that down.
What?
You're psychic. Watch this. X squared minus 3. Something like that, you mean?
Yeah.
All right. Go for it.
Wait.
Wait,
Okay. Yeah.
would it be, 1.5?
1.5, that's adding. Yeah.
Would it be, well, x plus, well, would it be 3 and negative?
That would be negative 9. X squared minus 9 would work. Yeah.
Is it 3?
It has to be the exact same number both times,
Oh,
though.
okay. I was wondering.
Nice try, yes.
Like Rob said, is it prime?
It is prime.
Oh, yeah.
Oh, right.
It's prime.
That is so cool.
Now, I will give you a sneak peek teaser for Algebra 2. By the way, you're not going to have that for 2 years. In Algebra 2, this, by the way, this is a potential extra credit question on this test. But in Algebra 2, which you do not have to know now, for the purposes of our class, this is prime. Because we only factor things over round numbers and fractions. Here's what they would do in Algebra 2. This is totally sneaky. You do not have to do this. Everybody clear? This is not, oh my goodness, staying up till 11 at night the night before saying, I need to memorize this. No, you do not. Go to bed. People think it must be x plus something, x minus something, because it seems to fit the difference of 2 squares. It does. Square root of 3. What is the square root of 3? I don't know. 1.7 something. Isn't that sneaky?
That's just evil.
You do not have to do that. Not. Okay. If you think you can, there is a potential extra credit question on the test eventually that might do that. Just saying. Questions? There, I redeemed myself.
What?
Everybody good? Take out your worksheets, please. Go.
You said it might be an extra credit question. If it is, to write that and just with the square root.
Then yes, if it's an extra credit question, and if you do that, then you may get some. You do not have to do this on the in-class project. So the in-class project, if you run into this, it's prime. X squared minus 5, same thing, prime. Everybody good? All right. You're supposed to be doing 27 through whatever the last problem is. And they're going to give you some practice. Like they will have you FOIL some of these things, just so you can see the middle terms canceling, which you already did. But it's a little extra practice. Then on the next page, after that, you should, like a problem 30 something. Over page 6. There you go. 31 through 38. It says use any method whatsoever to factor. I will hint, number 31, 32, and 33 do factor by difference 2 squares. The new method we just learned. So the very first 3 problems are the very method you just learned. Once you go beyond that, then it could be any combination of anything. I will warn you, a few of these problems factor more than once. The first 3 do not. They're just practice. Let me glance around and see if there are any other prime. Hang on a second. Let me see.
What's the 3?
Hang on a second. blah, 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 blah. I see 4 of them that are prime. In the, from 31 through 50, I see 4 problems that are prime. So you might want to make a note of that. In 31 through 50, 4 of those problems are prime. If you've got more than 4 that are prime, go look again. And I will actually give you a teeny tiny hint on one of them. Last problem I'm going to write on the board. This. X squared plus 100. Any takers?
What? Oh,
What do you think?
it'd be X on
Maybe.
like both things.
I'll put a question mark here. Okay, X and X.
Yeah, and then 10. I
Okay.
mean, yeah, and then, yeah.
And then what?
Subtract, or add, or.
Add, wait.
Add,
Add, like this.
yeah.
The only problem is, you recognize this from yesterday? Yeah.
Would it be x minus 10, x minus 10?
Ah, let's try it.
No,
However,
it wouldn't.
that
It wouldn't.
has an issue too.
It wouldn't.
Yeah,
Could you do x plus 10, x minus negative 10?
that would be X plus 10 really.
Yeah.
Yeah, that would be this. There's, the reason, by the way, this is clever, and this is a logical guess. Watch this. This is really X plus 10 parentheses squared, which we did yesterday. That should be square the first, double the product, square the last, which would be X squared plus 20X plus 100, which doesn't fit. So this is a very logical guess. Same thing here. This would be X squared minus 20X
So it's
plus
prime.
100. This is prime. You might want to jot this down in your notes. The last thing in your notes, the sum. Anybody see the problem here? Why didn't it work? Yeah.
Because the difference between two squares, there has to be one negative.
Yeah, and what had to be in between in the first place?
A minus.
A minus. It has to be a square minus a square. If it's a square plus a square, write this down somewhere. The sum of two squares is always prime. I mean, unless you have a GCF or something. Unless somebody forgot a GCF and then that's not your fault, that's theirs. But anytime you have a sum of two squares, by nature that is prime. It will never factor, as far as we know. Everybody good? All right, you have 15 minutes. Go ahead and quietly and smoothly move desks around. Make sure you put them back before the end of the hour. Go to it. Careful. 7x squared good. And then there's a plus between. There's 7x squared x plus 2 plus 2 parentheses x plus 2. Actually, this is supposed to be a 7. Oh, I see. You pulled the 7 out in the first place. Okay, so huge parentheses. Oh, I see what you're doing. Yeah. Gotcha. You just moved it over to us now. Yes, please. Okay, people listening at home, see you later.